A skyscraper's crushing weight drives millions of tons straight into its deep foundation.
The flexible pile compresses under the load while its steel core carries the immense weight safely downward. Deep bedrock spreads the remaining load, locking the entire skyscraper into permanent structural equilibrium. A skyscraper's enormous weight pushes downward, but deep earth anchoring sends that crushing load far below unstable surface soil. Deep foundation elements carry the weight downward, sharing part of the load through the surrounding ground and transferring the rest into stronger earth below. Rock spreads the concentrated load into the earth, where downward weight meets upward ground resistance in stable equilibrium. Every second, a megatower's multi-ton weight drives downward, threatening to crush the soft soil beneath its foundation.
Deep earth anchors solve this. Steel tendons drilled deep into bedrock lock the foundation in place, turning downward gravity into balanced tension.
By anchoring the structure straight into the Earth's crust, gravity is neutralized, locking the skyscraper into permanent structural equilibrium.
Gravity drives the tower's enormous weight downward, and the foundation captures that load, dividing it into deep structural paths. Taipei 101 survives earthquakes. This is because its foundation reaches solid bedrock.
Deep anchoring transfers earthquake forces into strong bedrock. That's why deep earth anchoring keeps the tower stable during powerful earthquakes. When earthquakes strike, shifting bedrock creates violent sideways forces that can tear apart ordinary foundations in seconds. Instead of breaking, the flexible pile absorbs movement. Its outer layer compresses while the steel core bends and carries the earthquake force safely. The remaining energy spreads into the earth, keeping the foundation stable and the skyscraper standing after the earthquake ends. When earthquakes strike, ground motion pushes seismic energy into a skyscraper, forcing its structure to sway. Hydraulic dampers resist that movement, forcing fluid through tight passages and turning structural motion into heat. As the dampers dissipate the energy, the building's sway decreases, helping the structure remain stable through the earthquake.
Before a 101-story skyscraper could touch the sky, its entire 700,000-ton weight had to be nailed directly into the Earth's rocky crust.
When an earthquake strikes, deep foundation piles lock into bedrock and absorb the shock, keeping Taipei 101 standing.
Taipei 101's 380 deep piles spread earthquake energy through bedrock before it can reach the tower.
The steel box perimeter cage spreads powerful wind forces around the tower, keeping it stable. Steel outriggers stop the tower from twisting by sharing powerful wind forces across the entire structure. Millions of pounds push down. The reinforced concrete core compresses slightly, spreading the load safely into the foundation. The foundation transfers every ton of the skyscraper's weight deep into solid bedrock, keeping the entire structure stable.
At 1,000 feet, wind doesn't just push a skyscraper, it twists it. Without resistance, that torque shears standard foundations apart.
Enter the steel box perimeter cage. Instead of taking the twist head-on, this subterranean steel grid intercepts the torque, redirecting lateral by turning rotational violence into distributed tension. The tower stays anchored. That's how megastructures survive the storm.